Hello everyone, in this video we're going to review Unit 6 topic 6.11 to 6.14 of AB Calculus BC. Actually 6.14 belongs to AB Calculus AB, but I'm going to include it in this review. Now, question 1. We need to find the antiderivative of this one. So basically, we're going to let u equals the one inside right here. And then du equals negative 2 over negative 2s, right? ds. And then du equals ds over s, right? So we substitute back over here, we see that ds over s right here, actually du, right? So this guy turns out to be antiderivative of du over square root of 25. I can rewrite this one as 5 squared minus u squared, right? So I'm going to apply the formula antiderivative of du over square root of a squared minus u squared equals sine inverse of u over a plus c, right? Now remember, if you have antiderivative of ds over square root of 1 minus s squared, it's going to be sine inverse of s plus c, right? So this guy turns out to be sine of u over 5 plus c. But u equals this guy right here, so the final answer must be sine of ln negative 2s over 5 plus c. Now let's move on to question 2. So observe that if you take the derivative of s to the 4, you get s cubed, right? So then we're going to use u substitution, right? So let u be 5s to the 4 minus 2, right? So du equals 20s cubed, right? ds. Now 80 right here can be written as 4 times 20, right? So I'm going to multiply both sides by 4. So I have 4 du equals 80 s cubed ds, right? So this guy turns out to be antiderivative of 80 s cubed ds, actually 4 du's, right? So I put 4 in the front, I put du right here. And then this guy becomes 3 raised to the u, right? So this guy turns out to be 4 times 3 to the u over ln 3 plus c, right? And then it's going to be 4 times 3, u equals this guy right here, right? So it could be 5s to the 4 minus 2 over ln 3 plus c. This one is the final answer. Now question 3. Observe that if you let u be the one inside parenthesis and you take the derivative, it's going to be s cubed right here, right? So I'm going to let u be 4s to the 4 minus 2. Then du equals 16s cubed ds, right? So this guy becomes 16s cubed ds, actually du, right? So I put du right here. Now I have secant squared of u, right? Now antiderivative of secant square is going to be tangent, right? So it could be tangent u plus c. But u equals this one, so it could be tangent of 4s to the 4 minus 2 plus c. This one is the final answer. Now question 4, similar to question 1. Alright, so I'm going to leave this one for you to practice. I just give you the answer. Alright, so the answer must be 2 ln absolute value of negative 1 plus ln 4s plus c. Now question 5. Observe that you have degree on the numerator is bigger than denominator. You need to do long division, right? Alright, so I have s to the 5th minus 5 s to the 4 plus 9s minus 42 divided by s minus 5, right? S to the 5 divided by this one, s to the 4, right? Multiply this one back, it's going to be s to the 5 minus 5s to the 4, right? And when you subtract, it's going to be 0, right? Now I'm going to bring 9s minus 42 down. So 9 divided by 1 by here is going to be plus 9, right? Multiply this one back, it's going to be 9s minus 45. Subtract them, it's going to be 3 left. So this guy can be written as antiderivative of this guy right here, right? S to the 4 plus 9 ds plus antiderivative of the remainder is 3 right here over s minus 5. Now antiderivative of this one is going to be s to the 5 over 5 plus 9s plus 3 times now the log of absolute value of s minus 5 plus c. This one is the final answer. Now question 6, observe that if you let u be this one, when you take the derivative, it's going to be the top, right? So let's u be 5s squared plus 5. Then du equals 10s ds, right? So I'm going to multiply both sides by 5. So it could be 5 du equals 50 s ds, right? So this guy becomes antiderivative of 5 du over secant u, right? 1 over secant is going to be cosine, right? So it could be antiderivative of 5 cosine u du, right? And then antiderivative of cosine could be sine, right? So it could be 5 sine u plus c, right? And u equal this one right here. So you have 5 sine of 5s squared plus 5 plus c, right? Now let's move on to question 7. Now remember we have the formula antiderivative of du over a squared plus u squared equals 1 over a arctangent of u over a plus c, right? So we need to make this guy the same thing as this guy, right? So this guy can be written as antiderivative of the bottom actually 4 square 5s square all together square, right? Now the top, observe that 10s ds actually derivative of 5s square, right? Now this guy and this guy the same thing. Look, this is u, this is u. So you can apply this formula directly, right? So this guy turns out to be 1 over 4 arctangent of 5s squared over 4 plus c, right? Now let's move on to question 8. Observe that the degree on the numerator is less than the degree on the denominator. We need to do partial fraction decomposition, right? And observe that this guy is the repeating linear factor. So this guy can be written as 2s squared plus s over s minus 2 times s plus 1 squared equals, first it could be a over s minus 2, the first factor right here, plus the second factor is going to be b over linear factor right here, s plus 1 only. And because this one is repeating, you see that? So you need to add c over s plus 1 altogether square. Alright, keep in mind, don't expand this one. If you expand this one, you're gonna get stuck. Now I need to rewrite this one as the common denominator, right? So the common denominator is s minus 2 times s plus 1 altogether square. This one right here, right? Now, I'm going to multiply the top bottom by s plus 1 square, right? So this guy turns out to be 8 times s plus 1 altogether square, right? Plus the second one right here, I miss s minus 2 and s plus 1, right? So b times s minus 2 times s plus 1, right? And the first one right here, I miss s minus 2, right? So c times s minus 2, right? So I have a times s plus 1 square plus b times s minus 2 times s plus 1 plus c times s minus 2 equals 2s squared plus s, right? Now I need to solve for a, b, and c. Now in order to solve for a, I'm going to let s equals 2, right? So that b and c disappear, right? So I'm going to let s equals 2. And then substitute 2 for s over here. So I have 2 plus 1, it could be 3 squared, it could be 9. So I have 9a. Substitute 2 for s over here, it's gone, right? Equals the right hand side. Substitute 2 over here, I have 8 plus 2, it could be 10. So a equals 10 over 9, right? Now to solve for c, I'm going to let s equals -1, right? So then this guy and this guy gone, right? So substitute -1 for s into this expression right here. I have -3c equals 1, right? Then c equals -1 third, right? Now to solve for b, you can let s be any number, right? So I'm gonna let s be 0, right? Substitute over here, I solve for b, right? So I have a plus, substitute 0 for s over here, you have -2b, right? Substitute 0 for s over here, you have -2c equals 0, right? Now a equals 10 over 9, so I have 10 over 9 minus 2 times b minus 2 times c, but c equals -1 third, so it will be plus 2 third equals 0, right? So -2b equals -16 over 9 right here, right? Then b equals 8 over 9, right? So finally, this guy becomes a equals 10 over 9 times 1 over s minus 2, right? b equals a over 9, so it will be plus 8 over 9 times 1 over s plus 1, right? And c equals -1 third, right? So minus 1 third times 1 over s plus 1 altogether square, right? And then this guy right here becomes entire derivative of this one, right? ds. Remember, you have entire derivative of du over u is to be ln absolute value of u plus c, right? Now observe that ds right here is the same thing as ds minus 2, right? So this one can be written as 10 over 9 entire derivative of d of s minus 2 over s minus 2, right? This guy and this guy must be the same, so that you're going to apply the formula right here, right? So observe that if I take derivative of ds minus 2 is actually ds, right? Because derivative of 2 equals 0, right? Same thing, I have plus 8 over 9 entire derivative of ds plus 1 over s plus 1, right? And then this guy right here is going to be -1 third. S plus 1 square, I print it to the top so I can apply the power rule, right? So it will be s plus 1 altogether to the -2, right? And then ds is the same thing as ds plus 1, right? So I put ds plus 1, right? So this guy turns out to be 10 over 9 times ln of absolute value of s minus 2 plus 8 over 9 ln absolute value of s plus 1 minus 1 over 3. This guy, you're going to add 1 over negative 2 plus 1. It's going to be negative 1. So this guy becomes positive, right? S plus 1 on the bottom, right? And then add C. This one is the final answer. Observe that you have the square root cosine. This is more complicated than this guy, right? So I'm going to rewrite this one as antiderivative of square root cosine s times sine to the fifth, right? So I just write sine s ds right here. I have sine to the 4 left, right? So sine to the 4, which means sine square altogether square, right? So this guy is the same thing as antiderivative of square root cosine s times sine square is going to be 1 minus cosine square of s, right? Altogether square times sine s ds, right? So I'm going to let u be square root cosine s, right? I'm going to square both sides, so I have u square equals cosine s. Now I'm going to take the derivative of both sides, so I have 2u du equals negative sine s ds, right? So I'm going to multiply both sides by negative 1, so this guy becomes positive, this guy becomes negative, right? So I'm going to substitute back over here, so I have antiderivative of this guy, actually u, right? And then this guy right here, actually negative 2u du, right? So I have negative 2u squared, right? And then I have this guy left right here. It's going to be 1 minus, look, u squared equal cosine s. Now this is cosine square, it's going to be u to the 4, right? Like this. And then square du, right? So I'm going to expand this one, so it could be bring negative 2 to the front, so negative 2 antiderivative of u squared times use a complete square formula to expand this one. It's going to be 1 minus 2u to the 4 plus u to the 8 du, right? So I just distribute this one, so it could be negative antiderivative of u squared minus 2u to the 6 plus u to the 10 du, right? Now take antiderivative of this one, so I have negative 2 times u cubed over 3 minus 2 over 7 u to the 7, right? Plus 1 over 11 u to the 11 plus c. Now I substitute square root cosine for u, right? So finally I have the answer. It's going to be negative 2 times 1/3 square root cosine s altogether cubed, right? Minus 2 over 7 square root cosine s altogether to the 7, right? Plus 1 over 11 square root cosine s to the 11, right? And then plus c. So it's going to be negative 2 times 1/3. Now square root cosine s cubed can be written as square root cosine s squared times square root cosine s, right? So it's going to be cosine s square root cosine s, like that, right? Same thing, negative 2 over 7 square root cosine s to the 6, right? So it could be cosine S cubed, right? Times square root cosine S, right? Similarly, at 1 over 11 cosine S to the fifth, right? Times square root cosine S altogether plus C, right? This one is the final answer. Now let's move on to question 10. For question 10 right here, we need to apply the formula 1 plus tangent square of u equals secant square of u, and derivative of secant u is going to be u prime times tangent u times secant u, right? So this one can be written as antiderivative of tangent square of 2s secant square of 2s altogether square times tangent 2s secant 2s, right, ds. So now we're gonna let u be secant of 2s, then du equals 2 tangent 2s secant 2s ds, right? Now we substitute over here, so we have this guy becomes antiderivative of tangent square up to s, actually secant square up to s subtract 1, right? But secant up to s for u, so I have u square subtract 1, right? Times, and let u equal secant to s, so this guy becomes u to the 4, right? And then this guy right here actually du divided by 2, right? So I have du over here, and it's going to be 1/2 right here, right? Now I just distribute this one, so it's going to be 1/2 antiderivative of u to the 6 minus u to the 4 du, right? And then it's going to be 1/2 times 1 over 7 u to the 7, right? Minus 1 over 5 u to the 5th, right? Plus c. Substitute secant to s for u, so the final answer must be 1 over 14 secant 2s to the 7, right? Minus 1 over 10 secant 2s to the plus c. This one is the final answer. Now let's move on to question 11. Question 11 similar to question 10 but easier. Alright, so we're gonna let u be the one inside parentheses right here. So we have u equals secant of negative 3s, right? Then du equals negative 3 tangent negative 3s times secant of negative 3s ds, right? So then I will multiply both sides by 3. So this guy turns out to be 3, and this guy turns out to be negative 9, right? Because I have negative 9 right here. So this guy becomes antiderivative of this guy right here and this guy right here. Actually, 3 du, right? So I put 3 right here and du right here, right? And I have this one secant square left right here, right? And this guy right here actually u, right? So we go like this, right? So this guy becomes 3 tangent u plus c. But u equals this one, so it could be 3 tangent of secant of negative 3s plus c, right? Now let's move on to question 12. I don't have enough space, so I'm right over here. Now you have the exponent and you have the trig. So we're going to use the acronym L, I, A, T, E, right? the best way to memorize this formula is lion 8. Okay, so we're gonna check. L stand for log, we don't have log. I stand for inverse trig, we don't have it. A stand for algebraic, we don't have it. T stand for trig, we have trig right here, right? So we're gonna let U be cosine S, right? Then du equals negative sine S ds, right? Now dv equals e to the negative s ds, right? Then v equals negative 1/2 e to the negative 2s ds. Remember, you have antiderivative of e to the as plus b ds is to be 1 over a e to the as plus b plus c. Similarly, you have sine of a s plus b ds is to be negative 1 over a cosine of a s plus b plus c, right? Or cosine, you do exactly the same thing, right? So remember, I have the antiderivative of u dv equals u times 3 minus antiderivative of v du, right? So keep that in mind. Now I use this formula, so this guy turns out to be, this why I call this m, right? So I have m equals u times 3, u is this one, v this guy, right? So I have negative 1/2 e to the negative 2s cosine s, right? Minus antiderivative v du. V is right here and du right here. So you have negative side right here and negative side right here becomes positive, right? And I bring 1/2 to the front, so I have negative 1/2 e to the negative 2s sine s ds, right? Now, for this one right here, I'm going to use the integration by part again, right? So, I'm going to let u be sine s, and then du equals cosine s ds, right? dv equals e to the negative 2s ds, and then v equals negative 1/2 e to the negative 2s, right? So, m becomes negative 1/2 e to the negative 2s cosine s minus 1/2, I rewrite, multiplied by u times 3. U is right here and v is right here, right? So I have negative 1/2 e to the negative 2s sine s minus v du. V right here and du right here. So negative and negative right here becomes positive, right? 1/2 antiderivative of e to the negative 2s cosine s ds, right? Now m equals negative 1/2 e to the negative 2s cosine s. Distribute negative 1/2, so it will be plus 1 over 4 e to the negative 2s sine s, right? Minus 1 over 4, right? E to the negative 2s cosine s ds, right? Now this guy actually m, right? So for this one right here becomes negative 1 over 4 m, right? So I'm gonna add 1 over 4 m both sides, right? So it's gonna be 5 over 4 m equals negative 1/2 e to the negative 2s cosine s plus 1 over 4 e to the negative 2s sine s, right? So I'm going to multiply both sides by 4 over 5. So m equals negative 2 over 5 e to the negative 2s cosine s, right? plus 1 over 5 e to the negative 2s sine s. Now you can factor 1 over 5 e to the negative 2s out. So it will be e to the negative 2s over 5. Right? It's going to be sine s minus 2 cosine s plus c. This one is the final answer. Alright, now we have a shortcut formula to do this one faster. Alright, so better you memorize the formula to do the MCQ. It helps you a lot. Alright, so if I have antiderivative of e to the as sine bs ds, it's going to be e to the as over a square plus b square times a sine bs minus b cosine bs plus c. Alright, second one, antiderivative of e to the as cosine bs ds equals e to the as over a square plus b square times a cosine bs plus b sine bs plus c. Alright, to memorize this formula, you look at the pattern. Look, this guy always the same, right? It doesn't matter sine bs or cosine bs, right? Now this is sine bs, and then you have a right here times sine bs first. The second one should be b times cosine bs, so you just swap the negative side. Now this one right here, cosine bs, so you have a right here times cosine bs first, and the second one, because this is cosine, so it will be positive, right? b times sine bs right here. Alright, so keep in mind, if cosine ps right here, then you should have the positive pairs right here, right? If sine ps right here, and then you should have negative side right here, swap plus 2 minus, right? Now I'm going to give you other 2 examples for you to practice. You're going to use integration by parts, and you're going to use direct formula right here. Make sure they both have the same answer, right? Now, number 1, antiderivative of e to the negative 2s sine 3s ds. The second one, antiderivative of e to the 3s cosine 2s ds. Now let's move on to question 13. So we need to use the trig identity to do this problem. We have sine 2s equals 2 sine s cosine s, right? And then you have sine 4s. Remember, this angle right here always double this angle. You see that? So sine 4s should be 2 sine 2s cosine 2s, right? So I'm going to replace this one right here with sine 4s. So it will be antiderivative of sine 4s ds, right? So it will be negative 1 over 4 cosine 4s plus c. This one is the final answer. Remember, we have antiderivative of sine as plus b equals negative 1 over a cosine of as plus b plus c, right? Similarly, you have cosine of as plus b ds equals 1 over a sine of as plus b plus c. So keep that in mind. Now let's move on to question 14. We just manipulate this one a little bit. So it will be antiderivative of 20, 25. Cotangent s is going to be cosine s over sine s, right? And then cosecant s is going to be 1 over sine s, right? ds. So this guy turns out to be 20, 25 antiderivative of cosine s over sine square of s ds, right? So we're going to use u substitution, right? So we're going to let u be sine s, and then du equals cosine s ds, right? So we substitute back over here, so we have this guy becomes 20, 25 antiderivative of du over u squared, right? So it's going to be 20, 25. Now we're going to use the power rule, so it should be negative 1 over u plus c, right? So it could be 20, 25 over u equals sine s, right? So it could be sine s right here. Don't forget negative side right here and plus c. This one is the final answer. Another way to do this problem is to memorize the formula. Remember, we have derivative of cosecant s is going to be negative cosecant s cotangent s plus c, right? So then antiderivative of cosecant s cotangent s ds is going to be negative cosecant s, right? So this guy right here becomes 20, 25 antiderivative of cotangent s cosecant s ds, and it's going to be negative 20, 25 cosecant s plus c, and then it's going to be negative 20, 25 over sine s plus c, right? Now question 15, observe that this one actually the product rule. So if you have f of s times g of s altogether prime, right? So it could be f prime of s times g of s plus g prime of s times f of s, right? Now if you take antiderivative of this one, it's go back to this one, right? So the final answer must be f of s times g of s plus c, right? This one is the trig substitution. Observe that this guy is the even power and this one is the odd power. You need to write the one with the odd power in terms of the one with the even power. So keep that in mind. So this guy turns out to be the integral form pi over 4 to pi over 2, right? Sine square of s times cosine square of s times cosine s ds, right? Now cosine square of s, I can rewrite this one as 1 minus sine square of s, right? Now I'm going to do u substitution, right? So I have u equals sine s, right? So then du equals cosine s ds, right? Now I need to change the upper bound and lower bounds, right? So u equals, because u equals sine s, right? So s over pi over 4, it could be sine of pi over 4, it could be root 2 over 2. Sine of pi over 2, it could be 1, right? So this guy right here becomes the integral form root 2 over 2, right? 2, 1. Now sine square of s actually u squared, right? Times 1 minus u squared, right? And this one right here actually du, right? So it's going to be u squared minus u to the 4 du, right? So it's going to be 1/3 u cubed minus 1/5 u to the 5th, evaluated from root 2 over 2 to 1, right? So you substitute 1/5 for u. So it could be 1 over 3 minus 1 over 5. Subtract. Substitute root 2 over 2 for u. So it could be 1/3 times root 2 over 2 cubed, right? Minus 1/5 times root 2 over 2 to the 5th, right? Now we're going to simplify this one. So the first one right here becomes 2 over 15 minus the second one right here. Root 2 cubed, it could be 2 root 2, right? Divide by 8. So it could be root 2 over 4, right? And then have 3 right here. So it could be root 2 over 12, right? Similarly, it's going to be 4 root 2 over 32. So it could be root 2 over 8. So it could be minus root 2 over 40. Now to simplify this one further, we need to find the LCD of 15, 12, and 40. Actually 120. So the final answer must be 16 minus 7 root 2 over 120. Now let's move on to question 17. Alright, we're going to use the half angle formula, right? Remember we have cosine square of s equals 1 plus cosine 2s over 2. Sine square of s equals 1 minus cosine 2s over 2. Alright, so this guy turns out to be the integral from 0 to pi of 1 minus cosine of 2s over 2 ds, right? So it could be integral from 0 to pi of 1/2 minus 1/2 cosine 2s ds, right? So it's going to be 1/2 s minus 1 over 4 sine 2s evaluated from 0 to pi, right? So it's going to be substitute pi for s, so it could be pi over 2 minus sine pi equals 0, right? So the final answer should be pi over 2. Now let's move on to question 18. Now we're going to use acronym L, I, A, T, E, right? We're going to check the log. Yes, the log right here. So we'll let u equals ln 2s, and then du equals 2 over 2s ds, right? Or du equals 1 over s ds, right? Then dv should be the remaining one, which means 1 over s squared ds, right? So v equals negative 1 over s, right? So this guy right here, I call this m, right? So m becomes, remember, the antiderivative of u dv equals u times v minus antiderivative of v du, right? So we have u times v, u is right here and v is right here, right? So you have negative ln 2s over s, right? Evaluated from 1 to 3 minus the integral from 1 to 3 of v du, v right here and du is right here, right? So if you multiply this one, it's going to be negative 1 over s squared ds, right? So we're going to calculate this one, so it's going to be negative parenthesis ln of 6, right, over 3 minus ln of 2, right? And this minus and minus right here becomes positive, right? So plus. Now antiderivative of 1 over s squared, it could be negative 1 over s, right? So this guy becomes negative side again, right? So it could be 1 over s evaluated from 1, 2, 3, right? So this guy becomes ln 2 minus ln 6 over 3. Substitute 3 for s, so it will be negative 1 third. Substitute 1 for s, so it will be negative 1, and then negative it becomes positive, right? So final answer should be, I'm going to simplify this guy, right? So it should be 2 third plus ln 2 minus 1 third ln 6. This one is the final answer. Now let's move on to question 19. A tank contains 120 gallons of oil at time t equals 0 hours. So suppose you have a tank right here. At t equals 0, you already have 120 gallons, right? And then you're going to pump additional oils, right? So make sure you're going to add 120, right? Now, question A, we need to use the trapezoidal rule with 4 subintervals to estimate the number of gallons of oil in the tank at t equals 12 hours, right here, right? So 4 subintervals, so you have the first interval right here, second, third, and 4. The width right here is 3, 2, 4, and 3, right? And this one is the trapezoidal rule. Remember, the area of the trapezoid is given by the formula base 1 plus base 2 times the height divided by 2. So I'm going to multiply by 1/2, right? So the approximation is 120. This one is initial value plus 1/2. Base 1 is right here, base 2 is right here, and this one is the height. So keep that in mind. So it could be 8.9 plus 6.8 times 3, right? Plus 1/2. Base 1 is 6.8, base 2 is 6.4, right? Times the height right here is 2, right? Plus 1/2. Base 1 is 6.4, base 2 is 5.9 times the height right here 4, right? Plus the last one 1/2. Base 1 is 5.9 plus base 2 is 5.7 times the height 3, right? And if you use a calculator, your answer should be approximately 198.75 gallons. Now question B. A model for the rate at which oil is being pumped into the tank is given by the function g of t equal this one, where g of t is measured in gallons per hour and t measured in hours. Use the model to find the number of gallons of oil in the tank at t equals 12 hours. So you're going to use the fundamental theorem of calculus, right? Remember the integral from a to b of f of s ds equals capital F of b minus capital F of a, right? So then you have f of b equals capital F of a plus the integral from a to b of f of s ds right here, right? This one is the initial value. Initial value is given by 120 right here, right? So you have 120 plus the integral from 0 to 12, right? This one is 12 of g of t, but g of t is 3 plus 10 over 1 plus ln of t plus 2 dt, right? Now we're going to print up the calculator. The answer must be 197.975, right? Now let's move on to question 20. Water is flowing into the tank over 24-hour period. The rate at which water is flowing into the tank at various times is measured and the result given in the table below, where RT is measured in gallons per hour and T is measured in hours. The tank contains 150 gallons of water when T equals 0. So this one is the initial values, right? Now, question A. Estimate the number of gallons of water that have flowed into the tank over the 24-hour interval by using the midpoint remaining sum with 3 subintervals and values from the table. Alright, so 3 subintervals is going to be from here to here, from here to here, and the last one from here to here. Now, the width right here is 8. This one, 8, and this one is 8, right? Now, you have the midpoint remain sum, right? So the midpoint should be this guy right here, this guy, and this guy, right? So the value is 150 plus, right? Because this one initial value, right? You need to add this guy. Now you need to calculate the area of the rectangle using the midpoint, right? So rectangle right here, the midpoint right here, right? The height of the midpoint is 8.8 right here, and the width right here is actually 8, right? This one is 8.8, right? So you have 8 times 8.8 plus the second one 8 times 9.2, and the first one 8 times 8.1, right? Now we're going to print up the calculator. So we have 150 plus, I'm going to factor 8 out. So I multiply by 8.8 plus 9.2 plus 8.1, right? And then press enter. The answer is 358.8 gallons, right? Now question B. Estimate the number of gallons of water in the tank at the end of 24 hours by using the trapezoidal sum with 3 subintervals and values from the table. Now this one similar to the question 19a, right? So I'm going to leave this one for you to practice, right? The answer for this question is 354.4 gallons. Now question C. A model for this function is given by Wt equals 1 over 75 600 plus 20t minus t squared. Use the model to find the number of gallons of water in the tank at the end of 24 hours. Question C, similar to question 19b. I'm going to leave this one for you to practice. The answer should be 357.36 gallons. Question D. Use the model given in the question C to find the average rate of water flow over the 24-hour period, right? So remember, we have the average formula. It's going to be 1 over B minus A, integral from A to B of F of S ds. This one is the formula, right? So we're going to use this one. So we look at the table right here. It should be from 0 to 24, right? So it's going to be 1 over 24 minus 0, integral from 0 to 24, right? The model in question C is right here, right? So it could be, the answer is 8.64, right? Now, since this one is the average rate, so it should be gallon per hour, right? Now let's move on to question E. dt equals 2 times e to the 0.08 T. Models the rate at which water is draining out of the tank. At what time does the total water in the tank begin to decrease? So the total water in the tank at time t is modeled by A of t equals initial water plus the amount of water pumped into the tank, which means the interval from 0 to t of R of S ds minus the amount of water draining at time t. So it can be interval from 0 to t of d of s ds, right? So we're going to substitute value, initial values is 150, right? Plus the interval from 0 to t, r of s, actually this guy right here, w s ds minus the interval from 0 to t of ds equal this one right here, right? Now to find the times when the total water in the tank begin to decrease, we need to take derivative both sides, right? So we have a prime of t equals derivative of this one is 0. Derivative of this one you just substitute t for s, right? So it could be w of t minus substitute t for s over here, right? So it could be d of t, right? Now you need to find the critical number of this one. So basically you need to let this one equal to 0. It's the same thing as w of t equals d of t, right? So you solve for t, right? So we're going to use the calculator to solve this problem, right? So I'm going to print up the calculator. You're going to go to the home screen graph right here. We're going to put the first graph, WT is going to be right here, right? So F1 of S is going to be right, and then you just press enter. You have the graph right here. Now go ahead and adjust the window. Make sure you go to the number 4 right here, window zoom, and choose zoom fit, and it's going to be right here. Alright. The second one, you're going to go back to the graph, so you're going to hit tab right here. F2 of S is 2 times e to the 0.08 s, right? And you press enter, it's going to be right here. Within the interval 0 to 24, you see that one intersection right here. So you're going to press menu, analyze graph, intersection, this one right here, right? So go to the left, go to the right. The answer is 18. So you have t equals about 18 hours, right? Now if you use decimals, it's going to give you more accurate values. It's going to be right here. The answer is 18.043, right? So you have t equals 18.043 hours, right? Now you're going to substitute 18.043 for t into original one right here, right? To solve for this one, right? So I'm going to print up the calculator. Go to the home screen and calculate, right? So it's going to be 150 plus ds, then you're going to subtract, I'm going to copy this one, interval from 0 to 18.043 of 2 times e to the 0.08 s, then the s right here, press enter. The answer is 230.763 gallons, right? Now let's move on to question 21. A hot cup of coffee is taken into a classroom and set on a desk to cool. The table shows the range of T's at which temperature of the coffee is dropping at various times over an 8-minute period, where R T is measured in degrees Fahrenheit per minute and T is measured in minutes. When T equals 0, the temperature of the coffee is 113 degrees. Right? Now, question A. Estimate the temperature of the coffee at T equals 8 minutes by using the lab remain sum with 3 sub-intervals and values from the table, right? So, n right here equals 3, right? Now, the first interval right here, the second interval is right here, and the third interval right here, right? So, you have the width is going to be 3. This one should be 2 and this one should be 3, right? Now the left remains sum, so I have the temperatures. Initial one is 113, right? So you have 113 right here and it's getting cooler, right? You need to subtract, right? So subtract what? The left remains sum, right? So the left should be this guy, and this guy. Multiply by the width right here. So you have 5.5 times 3, right? Plus 2.7 times 2, right? Plus 1.6 times 3, right? And then if you use the calculator, it's approximately 86.3 Fahrenheit, right? Now question B. Use values from the table to estimate the average rate of change of RTs over 8 minutes. So you have average rate of change. Remember, you need to know the difference between average rate of change and average value of the function. Okay, they are completely different. So it can be L of B, which means R of B minus R of A over B minus A, right? Now R of B is going to be 8 minutes, right? Right here. 0.8 subtract 5.5, right? Over 8 subtract 0, right? So you have 0.8 subtract 5.5 over 8 subtract 0, right? So this one is approximately negative 0.588 degree, right? Per minute square, right? Because the rate unit is degree per minute right here. So when you calculate the average rate of change, it's going to be per minute one more time. So it could be minute square. Keep that in mind. Question C. A model for the rate at which the temperature of the coffee is dropping is given by the function right here, where y of t is measured in degrees Fahrenheit per minute and t is measured in minutes. Use the model to find the temperature of the coffee at t equal 8 minutes, right? So the temperatures at 8 minutes equals initial value is 113, right? And then you need to subtract the interval from 0 to 8 of this one right here. 7 e to the negative 0.3 t dt, right? So you're going to print up the calculator. It's going to be 113 minus, I'm going to copy this one down over here. Press enter. The answer is 91.783, right? Now question D. Use the model given in part B to find the average rate at which the temperatures of the coffees is dropping over the 8 minute period. Alright, so again, as I told you, the average rate change is different from the average rate, right? Remember. So the average rate is given by the formula 1 over b minus 8 integral from a to b f of s ds, right? So this guy is the same thing as 1 over 8 minute periods, which means 8 minus 0, the integral from 0 to 8, right? The temperatures of the coffee is dropping, so we're going to use the model right here. So I'm going to bring up the calculator. Alright, so I copy this one down over here, and then I need to multiply this one by 1 over 8, right? And then press enter. The answer is 2.652 degrees per minute, right? So I'll get a 2.652 degrees per minute. Now let's move on to question 22. This question comes from AB Calculus Exam 2001. AB Calculus AB question 2 and BC question 2. This question is similar to the question 19, 20, and 21 we just did, right? So I'm going to leave this one for you to practice. I'm going to give you the answer key for this one, right? So question A over here, the answer is about 25.1 degree per day, right? Now question B, we need to find the average values, right? So we're gonna apply the formula 1 over b minus a, the integral from a to b of f of s ds, right? Similar to the one we just did above, right? So I'm going to give you the answer for this question. It's about 25.757 degree per day, right? Now question 23. This comes from AB Calculus Exam 2004, AB question 3 and BC question 3. This one similar to the previous one, right? I just give you the answer key, and then I'm going to leave this one for you to practice. The answer is 229 miles. The answer is 5.916 miles per minute. Now let's move on to question 24. This question comes from AB Calculus Exam 2005, AB 3 and BC 3. A metal wire of a length 8 cm is heated at one end. The table below gives selected values of the temperature T of S in degrees Celsius of the wire as centimeters from the heated end. I estimate T prime of 7. Alright, so basically we need to use the mean value theorem, right? So we have the mean value theorem is given by formula f prime of c equals f of b minus f of a over b minus a, where c is between a and b, right? So look at this one, 7 right here between 6 and 8, right? So I have t prime of 7 equals t of 8 minus t of 6 over 8 minus 6, right? T of 8 equals 55 minus T of 6 equals 62 divided by 8 minus 6, right? If you simplify, it's going to be about negative 3.5 degree per centimeter, right? Question B. Write an integral expression in terms of T of S for the average temperature of the Y. Alright, so the formula is going to be, now estimate the average temperatures of the wire using the trapezoidal sum with 4 subintervals. Alright, so basically we have 1 over 8 times, now the trapezoidal sum 4 subinterval, right? So we go back over here. This one is the first interval, right? Second interval, third interval, and fourth interval right here, right? So we have the height right here is going to be 1. The height right here is 4. The height right here is 1. The height right here is 2, right? Base 1 is 100. Base 2 is 93, right? And base 1 is 93. Base 2 is 70, right? Base 1 is 70. Base 2 is 62, right? And base 1 is 62 and base 2 is 55, right? So we have base 1 is 100 plus base 2 is 93, right? Times the height should be 1, right? Divided by 2. Plus base 1 is 93, base 2 is 70, times the height is going to be 4, divided by 2, right? Plus base 1 is going to be 70, base 2 is 62, times the height is going to be 1, divided by 2. And the last one, base 1 is going to be 62, base 2 is going to be 55, times the height is going to be 2 and divided by 2, right? Now if you use a calculator, the answer must be about 75.688 degrees, right? Question C. Find the integral from 0 to 8 of t prime of s ds and indicate units of measure. Explain the meaning of this one in terms of the temperature of the y. Alright, so basically we're going to use the fundamental theorem of calculus, right? So the integral from 0 to 8 of t prime of s ds equals t of 8 minus t of 0, right? And then t of 8 equals 55 right here. T of 0 equals 100, right? So you have 55 minus 100 is going to be negative 45 degrees, right? Now you're going to explain the meaning of negative 45 degrees. So you're going to say the temperature drops 45 degrees from the heated end of the y to the other end of the y, right? Now let's move on to the last question, question 25. AB calculus exam 20 OSIT AB4 and BC4. A rocket A has a positive velocity v of t after being launched upward from an initial height of 0 feet at time t equals 0 seconds. The velocity of the rocket is recorded for selected values of t over the interval 0 to 80 seconds as shown in the table below. Question A. Using correct units, explain the meaning of this guy in terms of the rocket flight. Alright, so look at the velocity right here. It's going to be positive, right? So you need to say, since the velocity is positive, the integral represents the distance in feet traveled by the rocket A from t equals 10 to t equals 70 seconds, right? Because when you take antiderivative of velocity function, it becomes the distance function, right? So keep that in mind. Now question B. Rocket B is launched upward with an acceleration at t equals 3 over square root t plus 1 feet per second at time t equals seconds. The initial height of the rocket is 0 feet and initial velocity is 2 feet per second. Which of the two rockets is traveling faster at t equals 80 seconds? So let Vb of t be the velocity of the rocket B at time t, right? So does that mean Vb of t is actually the antiderivative of 3 over square root t plus 1 dt, right? Because the derivative of velocity function actually the acceleration function, right? So when you take antiderivative of this one, it's gonna go back to the Vt, right? So keep that in mind. So in order to calculate the antiderivative of this one, we just rewrite this one as 3 times antiderivative of t plus 1 power up negative 1 half, right? And then dt right here should be d of t plus 1, right? Because d of t plus 1 is exactly the same thing as this d, right? So then this guy becomes 3 times t plus 1 power up negative 1 half plus 1 is going to be 1 half, right? Over 1 half plus c, right? So then multiply the top bottom by 2. So it could be 6 square root of t plus 1 plus c, right? Now at t equals 0 seconds, the velocity is 2 feet per second, right? So we're going to use this initial condition to solve for c, right? So I have this guy right here, actually 2 equals 6 square root of, substitute 0 for t, right? So it'll be 0 plus 1 plus c, right? So c equals negative 4, right? So then you have VB of t equals 6 square root of t plus 1 minus 4, right? Which of the two rockets is traveling faster at t equal 80 seconds? So we substitute 80 for t, so right? So VB of 80 equals 6 square root of 80 plus 1 is going to be 81 minus 4, right? Square root of 81 is 9. 9 times 6 is going to be 54. Subtract 4 is going to be 50, right? Now we need to calculate VA of 80, right? So we go back over here. It's going to be right here, 49, right? So, sin 50 greater than 49, we can conclude that the rocket B traveling faster at time t equal 80 seconds than rocket A. It's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand